Good day, trainees. I'm Engineer Idris Umar Audu, and I will be taking you on measurement. The learning objectives are to determine accurate distance of two or more segments by ranging. 2, to conduct a survey of a small area by applying the techniques of measurement, and also 3, work out the area of irregular shape at the site. We have physical quantities. Physical quantities are quantities that have measurable physical properties. They consist of numerical value and unit and are classified into 2. 1, fundamental physical quantities and derived physical quantities. The fundamental physical quantities are basic quantities that provide the basic units of measurement. Example of 3 most important fundamental quantities are length, mass, and time. The standard units of measurement of these physical quantities are the meter, kilogram, and second, respectively. And by definition, length is a measure of the distance between separate and distinct points. Mass is a measure of the quantity of matter contained in a body. Time is a measure of duration of an event. Other related fundamental quantities are electric current, luminous intensity, amount of substance, and thermodynamic temperature. Derived physical quantities. Derived physical quantities are quantities obtained by combining 2 or more fundamental quantities. That is, they are quantities that can be obtained by multiplying or by dividing 2 or more fundamental quantities, as illustrated in the figure below. We have examples of the derived physical quantities are velocity, acceleration, force, and work, mass, length, time, temperature, electric current, amount of substance, luminous intensity. All these are examples of the fundamental quantities, and their units are kilogram for mass, meter for length, then second for time, Kelvin for temperature, ampere for current, mole for amount of substance, then candela for luminous intensity. For the derived unit and their units of measurement, force is a derived quantity and is measured in newtons. Work is a derived quantity and is measured in joules. Density is measured in kilogram per meter cube. Electric current in coulombs. Power is measured in watts. The momentum is measured in kilogram meter per second squared, or Newton second. Linear measuring instruments. Linear measuring instruments include the meter rule, the tape rule, micrometer, screw gauge, and vernier calipers. The use of a particular instrument depends on 1, the distance, size, and shape of what is to be measured, and 2, its degree of accuracy. The unit of measurement of length is the meter, as I've earlier mentioned, which is defined as the length of the path traveled by light in a vacuum during a time interval of 1 divided by 299,792,458 seconds. Other related units of the meter expressed in multiples and submultiples of 10. 10 millimeters make 1 meter. 100 centimeters make 1 meter. 1,000 millimeters make 1 meter. Then 1.16 kilometer make 1 mile. And 25.4 inches make 1 meter. 12 inches make 1 feet. And 1 feet equals to 0.304 meters. 3 feet equals to 1 yard. The meter rule. The meter rule is a standard solid instrument, either made of wood, steel, or plastic. It is graduated in centimeters and millimeters and used to measure lengths of not less than 50 millimeters. Errors associated with the use of this instrument are 1. Zero error, and 2. Parallax error. The zero error occurs as a result of the damage done at the edge or ends of the meter rule due to wear. 2. The parallax error. This occurs as a result of the thickness of the rule and should be avoided by ensuring that the eye is placed vertically above the mark to be read, if the meter rule is placed horizontally. For vertical reading, place the eye horizontally along the level of the mark to be read. Then the tape rule. The tape rule is a reliable rule used to measure short or much longer lengths, which cannot be conveniently measured by use of a meter rule. The vernier caliper. The vernier caliper or vernier calipers are used to read lengths more accurately than the meter rule. It consists of a main scale with fixed jaws at one end and a vernier scale which slides over the main scale. The vernier scale measures fraction of the smallest division on the main scale. 2. External distance on solid objects are measured using the outside jaws, while the inside jaws are used for such measurements as the internal diameters of tubes. In order to obtain the required fraction of the smallest unit on the main scale to the nearest 0.01 centimeter, the 9 millimeter length scale of the vernier caliper is divided into 10 equal parts so that the difference in length between the vernier division and that of the main scale is 0.1 millimeter or 0.01 centimeter. Based on this, the vernier caliper can say to have a reading accuracy of 0.01 centimeters. How to read the vernier caliper? Number 1, take the reading of the main scale, which immediately precedes the zero mark on the vernier scale. Number 2, note the vernier mark which coincides with the mark on the main scale. 3, count the number of marks on the vernier from the beginning to that point, since each mark on vernier is 0.01 centimeters. Record the vernier scale reading. Number 4, add readings obtained on main scale with that of the vernier. Hence, the complete reading will now be 4.06 centimeters. Micrometer screw gauge. The micrometer screw gauge is an instrument used to measure the diameter of a thin piece of wire. It has a higher reading accuracy than the vernier caliper. It consists of a main scale graduated in millimeters and a circular vernier scale that has 50 divisions on it. A division on the vernier scale is equivalent to 0.01 millimeter or 0.001 centimeter on the main scale. How to use the micrometer screw gauge? First, close the gap between the anvil and the spindle until they meet. Take note of the zero error, if any. 2. Unscrew the instrument and place the object to be measured in between the anvil and the spindle and close the gap with the object in between until the object is firmly gripped by the anvil and the spindle. 3. Record the reading on the slip to the nearest decimal place. Then record the reading on the thimble, which is the circular scale. Finally, add the two readings and record the value obtained. Remember to add or subtract as the case may be if there is any zero error. Pressure in liquids. Pressure by definition is force per unit area, the force that acts per unit area. So, and pressure, we are made to understand that pressure increases with depth of liquid. Pressure in different liquids at the same depth varies directly with density. Pressure at any point in a liquid acts equally in all directions. Pressure at any point at the same depth within the same liquid is the same. At this point, I think I can say that we have discussed the fundamental physical quantities like the length, mass, and time with their units. We have also discussed on the derived quantity of the derived physical quantities like velocity, acceleration, force, and work with their units. We have also learned on the linear measuring instruments such as the meter rule. We have also discussed on vernier caliper, meter rule, tape rule, and micrometer screw gauge. Not only that, we have studied pressure in liquids, where we are made to understand that pressure in fluids or liquids increases with depth of that liquid. We also made to understand that pressure in different liquids varies directly with the density of that liquid. We also made to understand that pressure in a liquid at any point acts in all directions. So kindly refer to our course materials online for more information. I still remain Engineer Idris Umar Audu. Thank you very much.